Okay. 7.2 now. 7.2, same idea, 4 more rules. Here's how they work. Starting with constructive dilemma. Constructive dilemma says, let me just read what it says, right? If P then Q and if R then S. P or R, therefore Q or S. If you have two if-then statements combined into a single line, if P then Q and if R then S, and you know that one, you don't know which, but one of the antecedents is true, then you can validly infer that one of the consequences is true. You don't know which, but if it's either P or R, well then it's either Q or S, because if it's P, it's Q, and if it's R, it's S. So, two if-then statements, when the antecedents are in an or statement, then you can conclude an or statement with the consequence. And a proof, again, works the same way. If you know that if you have a line like this and a line like that, then you can derive a line like this. Simplification. Remember, with an and statement is only true, or conjunction if you rather, when both of its parts are true. Well, then if this and statement, P and Q is true, that means that P is true and Q is true. So if you know that they're both true, then you can say that one of them is true by itself. That's all simplification is. It only works with and, it doesn't work with or if then, of course. But if you have an and statement with two terms, then you can conclude one of them. I should warn you now, you can conclude Q, but Hurley won't let you. He makes you use another rule that's coming up to switch these first. He'll only let you derive the first one. So it goes. And remember, in all these, in this case, P and Q, these are just models. P might be a complex statement, like A or B. A or B and Q, well then, A or B. That fills in the place for P in our model. You're using this sheet that I put up on Blackboard for you to follow along, right? Let me get this back where it was so I don't get confused. Okay, over here now, conjunction. Conjunction says, if you know that two things are true separately, well then you know they're true together. So, we have a line that tells us P is true, we have a line that tells us Q is true. So we can say P and Q are true, both at the same time. So just to give you a kind of a hint here, you notice that this one has an and statement. What you might find in a proof is like a line that says P or if P then Q, a line that says if R then S. You can take those and stick them together. If you know that this is true by itself and this is true by itself, then you can put them together and say that they are both true at the same time. That's all this is. It's all conjunctions. Two things known to be true separately, we can say that they're both true. That's all. Addition. This is the one that's going to kill you. Remember that for an or statement, only one of the two disjuncts has to be true. So if you know that P is true, then you can say P or Q. As long as this is going to be true, right? Think of your truth tables again. As long as P is true, then P or anything will be true. And it doesn't have to be P or Q. When you add, two things to be aware of. The first is that when you add, we want to say that addition is and, but not in logic. For addition and for our purposes, we have to use or. Because we don't know that P and Q are both true, we just know P is true. So we can say P or anything, right? That would be one thing to keep in mind. The second thing to keep in mind is anytime you're constructing a proof and the conclusion contains a term that's not in the premises, there's only one way to get a new letter into the game, and that's with addition. By the way, you don't have to just add or Q. You could add or, if P is true, then P or, I don't know, it is false that if A, then, I don't know, G if and only if R. You can do that. That's fair. Seems a little weird. But remember, as long as P is true, then this whole statement is true. Doesn't matter what we add. As long as P is true, the P or anything will be true. And so, when you are stuck with, a proof where you know something is true, but you need another letter or something like that, addition is the only way you're going to get a new letter into the equation. Any question about any of that? I guess you'll have to email me if there is.